Today we are going to discuss one of the very important problem that is asked in a digital electronics gate question. So this is 2020. So one of the very important 2 mark that they ask. So the thing is that this is one of the numerically answer type question. So this for the component in the sequential circuit shown, TP is a propagation delay, setup time, hold time. So this we already see, right? So propagation delays every device will have. So setup time is the amount of time the input need to be maintained before the recent clock is applied. So hold time is that amount of time the output after the change in clock, the output even after the clock pulse change that need to be maintained. So that is what the setup and hold time. So the maximum clock frequency at which the given circuit can operate reliably. So this is the question that they ask. So now we are going to find how the things will work. Okay. So when we are taking the TPD, we have to check the three things. So first, how much delay that is caused by the component and how much delay that is caused by setup and hold times. So here let me start from the flip-flop 1. So here the propagation delay which is 3. So here it will be coming with a 3 nanosecond delay. So here 2 plus 2 which will be added. So here it will be come with a delay of 7 nanosecond. So this will come here as a 7 nanosecond plus the setup time 4 need to be added here. So here the total delay, how much time it need to wait is there. So 11 nanosecond it need to wait. So here let's start from flip-flop 2. So we have to analyze this logic separately and this logic separately because that only we have to take. So here the TPD is 8 nanosecond. So here the delay will come as 8 nanosecond and the setup time is 5. So here that need to wait for 30 nanoseconds. So the total delay TD which is will be equal to max of 11 comma 13. Okay, so max of 11 comma 13. So 13 is a max. So 30 nanosecond is the total TPD. So TD. So total delay is like this. So from there they are asking us to find the clock frequency. So we always need to find the total delays clock frequencies only. So which need to be less than or equal to 1 divided by 30 nanoseconds. So which is equal to less than or equal to 76.9 megahertz. Okay. So the answer that need to be the maximum clock frequency which will be prox equal to 77 or 76.9. So that is what the thing. So we can even take like this or even 77. So anything is fine. So this is the answer. So I hope you guys able to understand, right? So we need to calculate TPD plus setup time. So that is what the total delay. So that will be equal to this one. So I hope this is understood, and this is one of the pretty easy logic only. But on the time of while this question was asked, so these kind of awareness the students may not have. So that plenty of the students have written this wrongly only. So this is one of the very important question. Please make a note of it. So here another one question that is asked, I think in 2011, I think. So in the circuit as shown, the figure below, the assuming that the initial condition is 0, 0. So let me take the initial condition which is 0. Here 0 means it will be 1. So here also it is 0. Here it is 1. Okay. So then the states of Q0 and Q1 immediately after 33rd clock pulse. Okay. So they are asking us to 33rd. So the guys will do 1, 2, 3 up to 33. So that is not needed. So first let us find how this is. First thing is that we need to find whether this is synchronous clock, not synchronous. So clock is applied both. So this is a synchronous counter. Okay. So then now we have to analyze each state how that will be changing. Okay. So here the K0 output is 1. The Q1 bar is given here. So for first clock pulse, let me take blue color. So here the thing will be 1. So 1 plus 1. So after when first clock pulse applied, so when both the input is 1, the flip-flop output will be toggling. So that will be 1. So this state will be 0. So here previously the output was 0 and 1. So when 0 is to K, 0 is to J and the K which is equal to 1. So when we give 0 and 1 as output, then the output will be maintained as it is. So that will be 0 and 1. Now again the input here will be 1. So here it is 1. So here lead like this. So here it is 1. So 1 1 is given. So again this change will flop. So that is 0 and 1. So when 1 and 0 was given, the set the 1 is given to J and the 0 is given to K, then this state will be fixed to 1. So 1 and 0. Okay. So let's take the last thing. So here 0 is coming. So if the 0 is here, so 1 and 0 is coming here, then this will be changed to 0. So this will be 1. So if 0 and 1 is given, then again this will be changed to 0 and 1. So this is what the different state of things. So let me write Q0 and Q1. So Q0 and Q1. So let me write the Q0 Q1 here. So how the state changes will be like this. So I have already said, so when we are analyzing the flip-flop, change the states like this. Consider the state that is given as per the question. So they started with the Q0 and Q1. So let us also take like this as it is. So when 0 before 0 is applying, the initial condition was 0 0. So when first clock pulse is applied, so first clock pulse, that is our blue color. So when we apply the first clock pulse, the output is 1 and 0. So here 1 and 0. During second clock pulse, that is red green color. So that is 0 1. So during third clock pulse, that is yellow color, that is again 0 0. So here you see there is only 3 different states. So this is a mod 3 counter. Okay, so mod 3 counter. So now they're asking us to analyze up to 33rd clock pulse. So the quite easiest logic is that how we can solve this one is the 33 modulus of 3, which is equal to 0. So the answer is, what will be the answer at 0th clock pulse? So 0th clock pulse is 0 0. So the output will be 0 0. So if they're asking the output at 724th clock pulse, then 724 modulus of 3, so which is 2 1. So this is 2, here 1 4 1, so 1, so which is equal to 1. So at 1 the output is 1 0. So this is the output at 724th clock pulse. So this is output at 33rd clock pulse. Okay guys, so this is how we can solve questions in the synchronous counter. So we have saw plenty of question how to solve the synchronous counter, asynchronous counter, everything. So I hope this much understanding will be enough for you guys to get a good marks in the counter part. So next class, let's start about melee, more, those kind of missions. So state missions, let we start from next classes. So I'm winding up here, so leaving this to you. So if you guys have any doubt, please post in the comment section. I will be there to solve those things. Thank you guys, stay tuned.